So this video will quickly look at the decision tree. We will use a data which is part of a package called rpod, and this is about kyphosis. This is a type of deformation which is examined in children, and this is an outcome which has two states, present and absent respectively, and this is measured after a certain corrective procedure was performed on children, where we have number is the number of times the procedure was performed. Start is the topmost vertebra on which it is performed, and age is age of children expressed in months. So we're just looking at the first four columns here, and essentially we use decision trees to understand which variables among age, number, and start respectively are important contributors to understanding as to whether a particular deformation will be present or absent. So this is kind of a predictive analysis using decision trees. So I'll quickly reset this database because the two columns which were there as a part of operations that we did through decision trees. So I'll quickly refresh this, and now I have the original data set, which is this. So we have three columns, namely age, number, and start. These are the three independent variables, and we have the response variable as kyphosis itself, which is presence or absence of deformity after certain corrective procedure was performed. So that's the database. So after we understand the database, so let's quickly do a decision tree model, which is done through command rpod, and we are passing kyphosis, tilde, age, number, and start. So just to understand which particular factor is more important. And once we do the model, we can quickly do a plot to see a visual depiction of this tree. So essentially what it does, it tries to find out which particular factor would help us understand the contrast between presence and absence of a deformity. And so that's why it starts, in this case it starts with the vertebra on which the topmost vertebra on which the procedure was performed, and later it moves through the age, and then it basically tries to see how the contrast can be explained. So for example, you can see that on the left hand side we see complete absence of deformity, while on the right hand side we see presence of deformity. So that's how a decision tree could be used to understand what is the sequence in which partitions can be performed on one or more, using one or more independent variables, and a particular sequence in which these variables have to be used to explain why a deformity could still be there or it may not be there, right? So that depending on the values the class variable can take. So that's the essence of decision trees. So a better way to plot this is through fancy rpod plot command. So this allows us to, this is again part of the rpod plot package, and then we can see more information as to how effective this partition has been. So we start at the variables, independent variable start, which is essentially the topmost vertebra onwards the surgical procedure was performed, and then we move from that variable to age, and there's a partition on age where we can see the distinction is made between whether the age of children who underwent this procedure is greater than or equal to 15, or is it less than 55, and so on. So we have three different partitions on age, and then we can see how the contrast improves. So the better we are able to see the contrast, better we are able to filter out the conflicting or confusing entries. For instance, this 9%, this is not, this particular leaf of tree is not able to differentiate between what factors would contribute an absence or presence of deformity. So we have 43% on one side and 57% on another side, and this is not useful to us. But if you look at the extreme left side, we have a complete absence, which is fine because we're still in information. And similarly, on the extreme right hand side, we have a 42% versus 58%. This is also not giving us enough information. So I would restrict this to the 3 entries from the left side, which is mostly, it is giving us either 100% information or 86 to 14, which is still a very good contrast. So that's how the rules will be discovered.